Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface. And so far we have looked at more or less elementary ideas about Java native interface. So for example, how to overload or override methods, how to deal with object arrays, how to deal with primitive types, how to deal with strings. But now we need to get into more advanced topics, and one of the most important topics is how to access fields and methods of Java objects in C++. So let's start by looking at how we can access fields in C++, and the procedure is very similar to how we use the reflection API in Java. Basically, what happens is that when the JVM creates an object, it also creates a meta class, which is called a class. The type is called class, CLASS. And the class object stores all the information about the object that we have created. And JVM stores them in a memory area called the meta space. I believe the old name was permgen space. But from Java 8, they changed the name to meta space. So the meta space has all the meta information about an object, a Java object, all right? So we can start by looking at how the reflection API work in Java, all right? So let's look at how it works. And here I have a simple example. I'm creating a class called person, all right? And it has a field called name. So this class person has a field name which is a type of a string. The name of the field is name, which is the name of the person, and I have a public constructor which I can set the name of the person. Each person must have a name, all right? So we have a field, and a field in Java has access modifiers. So here I don't specify any access modifier, which means this field has default access level, which is the package level access, all right? So any other class that is inside the same package as this person can directly access this field name. And then we have a public constructor so that we can set the name, all right? And so we create this, and let's see how we can use the reflection API and the meta information to basically get access to this field and get the value of this name field. So we can use reflection API to access any field, even private fields of a class, of an instance of this class, which is the person. Even if this string is private, by default, we won't be able to access it, but the reflection API can in fact allow us to even get access to a private field, and I'll show you how to do that. For now, let's assume this has a default access, which means it's a package level access. So I go to another class, and basically in the main method I instantiate this person class with the name Bob, and I'm using the reflection API. So the first thing is that on this instance object person, I invoke the method getClass. This returns a class object which is parameterized. We don't need to care about this type, so I'm using a wildcard. And by default, we call it class, C-L-A-Z-Z. This is the convention we typically use, all right? So we get the class that represents the meta information or metadata of this instance object, this instance of this person class, which has a specific name. And then from this meta information, this class, we need to get an identifier for the field, right? So class get declared field, and we pass in the name, a string literal, which is exactly the name of the of the field, right? So this is a string literal that matches the name of the variable of the field, and this returns a field identifier. And with this field identifier, which comes from the class metadata of the instance object, we can invoke the get method on this field identifier and pass in the instance of the person object to get the value of this field, which had the name, right? So this f1.get, we pass in the object that we want, and then basically this returns an object, and if I send it to the print line, it converts it to a string, and we already know that this is of type a string, so we can actually see the name Bob, right? So just note that reflection API throws a lot of exceptions, because you may not have this field, the name might be wrong, the access level might not be, you may not be able to access the field. So if the field is private, you may not be even to access, run this f1.get person, you may not be able to do this. And also there are two types of get fields. One is get declared field, the other one is get field. So the difference here is that get field can only access the public fields. It cannot access the package level or default access or private field or protected field. But the get declared field can access anything, so it can return a field identifier even if the field is private. But then if the field is private, you won't be able to run this f1.get. You won't be able to invoke it, and it throws an exception saying that the illegal access or whatever. Okay? So from the object, we get the class identifier. From the class identifier, we get the field identifier. And from the field and the class, remember, field came from the class. We can pass in the person. So basically we have the field and the object itself to get the field that we want from the field identifier. So again, from the class to the field identifier to get the actual value of the field. And why am I repeating this? Because this will exactly happen in the C++ when we use the JNI. So the process of accessing field in C++ using JNI is pretty much similar to the reflection API. That's because JVM already knows all the information about a class or an instance of a class, because all the information is stored in this meta space. All right, so let's head to Eclipse and try to practice this reflection API, and then we jump into C++ and see how we can actually implement accessing the fields in C++ using the JNI. All right, so I'm going back to Eclipse, and I have in my workspace I have this native, which is a Java project, and native C, which is a C++ project. So I'm going to create a new package, and let's call it test7, and here I'm going to create a new class, which is my person class. And okay, so we want to have a string name, and obviously we want to have public constructor, so that the name must be set at the time of the constructing the object. String name, and this dot name is name. So just remember that when we have this constructor, the no-arg constructor is no longer available, which means we cannot instantiate a person without any name. Okay, so this is my person object. It's very routine. And then I'm going to create another class called test access fields. All right, and it's going to have a main method. I'm going to create a test1 method here, and in test1 I'm going to just practice the reflection API. So public static void test1, and we're going in test1 here, we're just going to practice reflection API. So let's instantiate a person is new person, and I'm going to pass in the name Bob. All right, and then we're going to create the class identifier. So a class of type which doesn't matter, class equals person get class. All right, and we can actually see the type here. It's basically a class that extends the person. Let's see if we can write person here. No, we cannot. It's more like capture one of extends person. It's a weird type, something like that. Yeah, I guess the wildcard just works fine. All right, So we get this class, and remember the class object is in java lang.class, and it's a parameterized type. And then we want to get the field identifier. So field f1, let's say, and let's also import this. And we're going to import it from java.lang.reflect, right? We're going to import it from the reflection package. And we're going to say class get field, and the name is name. All right, and this throws a couple of exceptions. Let's just throw them out of the method. No such field exception. So this name, the class might not have this name, this field, the name might be wrong, or security exception. We might have no access to it. And then this method, let's just throw it out of the main for now, all the exception. Let's run this. Now obviously this method get field throws an exception, no such field exception. Why? Because if you look at the documentation, see if I can zoom, get field returns a field object that reflects the specified public member. So you can only access the public members of a class using get field. All right, but in the person, this is a default access level, not the public. So this is not public, this is a package level access. Now in Eclipse, each package level access is denoted by this triangle, the blue. Public access level is denoted by a green circle, but this is not public, this is package level access. And get field can only access the public. So if I make this public, then yeah, I can access it. But for now, let's just keep it as a package level access. So if I cannot use get field, I can use get declared field. And get declared field can access any field, even if it's not public. So let's do a sysout on this field and see what information this gives us. So it says we have a field java.lang.string, and it's test7.person.name. All right, so we have this field identifier, and we had no problem. But then what we want to do is try to get the value of the field. And we already know that if I invoke f1.get on the object person, this returns what? This throws some exceptions: illegal argument exception, illegal access exception. Yeah, so the reflection API throws lots of exceptions, and let's just throw them out of the main. So this returns an object because the field could be anything and we didn't specify the type. So let's say object name obj, name object is f1.get. So let's see if we can run this. Yeah, we could run it. So let's do a sysout on the name object. And we get the value Bob, right? So this is in fact a string, and we could just cast it to a string. So name is a string name is basically cast to a string of the name object. And we can do the so this casting is not going to make any problems because this name object is going to be a string. The type is a string, and we still get, right? So what happens if I make this private? So now the field is private, and you see now so let's just comment this out, and let's just print the field identifier f1. And now it has another identifier which is private. So previously we had java.lang.string and test7 package.class.name of the field, which was name, right? But now it says it's private. But then how do we access the private? It's very easy. So you said, okay, f1, which is the field identifier, dot set accessible true. So even if this was private, now let's see if what happens if we print F1 again. It's still private, but now we can access it through the reflection API. So set accessible true means allow me to access this even if it's private. So the rest of should work fine. Yes, even if it's private, I was able to access it because I manually set the accessible field to true, right? So reflection API allows you to access any private member of any class if you want to. I mean, the condition is that you know the name of the field. Obviously, if you just read through the public API of a Java code, they don't expose the private field, but you can always decompile. Use any decompiler and decompile any class file, the .class file, and see all the code. But I believe when you decompile, it doesn't actually show the name of the variables, so that's something. But if you know the name of a private variable, you can always access it through the basically reflection API. So let's go back and try to make this default access again. So if I run this works fine. So as you can see, we use reflection API from the class metadata, get the field identifier, and from the field identifier we were able to get the value of the field as an object, and then we did a proper casting because we already knew the type of the field, and then yes, so and then pretty much exactly the same thing happens in C++. So what I'm going to do here, I'm going to create a native method, public native basically void print name, and I'm going to pass the person object, person, all right, to this class test access. Now obviously if we so what we're going to do next is to try to see what happens. Let's say how I can access this name field of this person object, person class in C++ using the JNI. And the goal is to get the value of this string, and we already know how to deal with strings in C++, the Java strings. So we know how to access the string, and now we want to see how to access it when the string is actually a field of a class, all right? So going back to our PowerPoint, we now know how the reflection API works, and if you understand this, then the C++ and the JNI process is very similar. So in this slide, I have the information on how to access the instance fields. Static fields are going to be very similar with a very small difference in which methods we invoke from the JVM. So in C++, we take the following steps for instance fields. Step 1, get the J class type of the object. So if I want to get the name field of a person, I have to get the J class identifier of this person. And again, it comes from the meta space, and it's very similar to this person.get class. It's pretty much the same. So we need a J class, so we ask the JVM to find this class, and it's package/class. So like we don't use the L or semicolon, it's just package class. For example, a string class becomes java/lang/string, okay? No L or semicolon, because this is not the signature of a object, this is just the class path. So we say that, okay, find this class for me, and here it's going to be the person class, and this returns a J class. And then the next thing, obviously, just like the reflection, that we got the field identifier, we ask the JVM to get us the field identifier, get field ID, and we pass in the identifier of the class, which is the J class that this find class returns. The name of the field, here it's going to be name, and then the signature of the field, and it's a object, a string object, so it's going to be L java/lang/string semicolon, all right? So the signature is different from the class path description. So here we use the signature of this field, which is a string object. And once we get the field ID, what do? We ask the JVM to get us the object field. If it's a primitive field, we get so JVM has all the primitive types. So we say get double field or get int field or get boolean field, and so on. Get short field, get double field, etc. And then the information that we need to pass to the JVM is the J class identifier, which is the identifier of the person, and then the J field identifier, which is this field ID for this string name. All right. If it's an object type, a string is an object, so we have to use the get object field, and again we pass the J class and J field ID. And then what happens is that this returns a J object, just like the f1.get, which returns an object. And then if we know the type of the object, which in this case is going to be JString, we can cast it to a JString and then ask the JVM to get the actual characters of this JString, and then we can print it to the console in C++. So if we know the type of the object, we do a proper casting from JObject, for example, in this case to JString. So here's the code. Step 1, get the class of the person, environment, find class, and this is the class path description. This is not the signature of the object. This is the class path description, which is the package / the name. Test7, this is in the test7 package, and the person class. And this returns a J class object, and I call it person class. So this is the class identifier of this person class. And then we need to get the field ID for this name field. So J field ID, FID, environment, get field ID. We pass in the J class identifier, the name of the field, and then the signature of the field. In this case, it's a string object. So L Java /lang /string semicolon. Now that we have the information of J class, J field, we can actually retrieve the field. So we say JVM, get us the object field, and we pass in the object person. And remember, this is the person that comes from this is the argument of the JNI function, and then the FID, right? So we need this J class to get the field ID, but we need to pass in the actually this is not J class, this is J object. This is the instance of the object that is passed to the C++ function. All right, because we are accessing the instance field, so that requires an instantiation of the class. And I get and this returns a J object. I call it name object, and I already know that this is a string, so I downcast it from the J object to J string, and then I ask the JVM that this is a J string, give me the characters, the native characters, the C++ characters of this J string as a character array, const char star. All right. And then we can use printf or stdcout, and because this character array is on the native heap, we have to ask JVM to release it and free the memory on the native heap, okay? Because the garbage collector doesn't really care about the native heap as much as it cares about the Java heap. So this is the whole process, and again, it's very, very similar to the reflection API, and that makes sense because it's more or less the same thing. But what you need to know is that really in C++, when we're accessing the field, it's a free access, so it doesn't matter if it's a private field or the public field or protected field. It doesn't really matter. Now in Java, in the reflection API, we had those exceptions, and if we wanted to access a private field, we had to manually set the accessible parameter to true. But in JNI C++, it doesn't matter. It gives us full access. So let's head to Eclipse. So far we have our person class, and then test access fields, and in this method we just use the Java reflection API. So I'm going to create another method called test2, and in test2 I'm going to use the basically JNI access C++. So public static void test2, and in test2 I'm going to instantiate this class test access field, test new test access field, and I'm going to invoke the print name, which is a native method, and obviously I need to instantiate a person and pass it to the native method. So this print name a native method, and what this method is going to do is it's going to access the instance field, the name field of this instance of this object. Okay, this is an instantiation of this class person, which has a specific name, and we're going to get the name field of this object and print it to the console. So what should we do? Step one is, let's go to our C++ perspective. Step one is to select this Java class and run our Java H tool to get the header file, and I have already configured it to put it in this header folder of my C++ project, so test7, and this is the generated header file. And now we go to our src folder and create a source file. Let's call this basically access fields.cpp, and the first step is to include the header file header and then test7. all right, and then from the header file we copy and paste this signature, and then the first parameter is environment. So we have two J objects, so you have to be careful here. The first parameter that comes always after the JNI environment is the reference to the calling class, which is basically this class, test access field, right? So the first J object is the calling class, a reference to the class, the object that is associated with this function. The second one, J object, is actually the person object, right? That we are passing as a parameter to this native method as an argument, right? So this is the person object. All right, so how do we call? So what is the goal? The goal is to access the name field in the person class, in the person object, this person, right? This one. This is a J object, and we want to access the name field. So step one, we need to get the meta information, the J class information of this person. So J class, let's call it person class, is JVM find class. Find this class for me, and it accepts a const char pointer, which is the class path ID. So I know that this is in test7 package, and then it's a person, right? So if I click on the person and go to my Java perspective, go to the bytecode view, you see this is the class path description, test7/person, all right? And then go back here. So this is a step one, get the class. Step two is field ID, field identifier, J field ID. FID is JVM. I'm asking JVM get field ID. We have to pass it the class or J class identifier, which is the person class. I want to get the field of this person object. What is the name? What is the signature? So the name, I already know that it's name. So what is the signature of this field? Again, I go back to my person class, person object, and then I click on this string field and go to the bytecode view. So this is the name of the field, and this is the signature of the field. It's a string, so L Java /lang/ string semicolon. So this is the signature. All right, don't forget to add the L and semicolon. So we get the field ID. Step 3 is get the field, and we know that this field ID, this is an object. So if I say if I say environment get object field, this asks me to pass in a J object, which is going to be this person, right? So this is going to person, the instance of the class of the object, and then the field ID is ID, all right? and this returns a J object as we expect. So J object basically name obj, and I already know that this is a string, so step 4 is a typecast. So J string name is J string name obj. All right, so I'm just, and then step 5 is to print the name to the console. How do we do that? We need to ask the JVM, because this is a string, Java string, so we need to ask JVM to get us the string UTF chars, get the character array representation of this Java string. So, and we don't care about the is copy, and this returns a const char pointer, which is a C style string, literal. So const char pointer basically name array. Okay, and then we want to printf this, so printf %s \n and with the name array. And then finally we want to, don't forget to release the native heap, because this character array is now on the native heap. So let's manually just release it and free up the memory environment. Again, we ask JVM, because JVM is managing the native heap, release a string UTF chars, and then the string, the address, or the J string, which is a pointer, is the name, and then the characters is the character array. All right, so we were able to get the class identifier, get the field ID, and then access the field, typecast it, and then get the string and then print it. So I'm going to the C++ perspective and then build this project. So the dynamic library is created, copy and paste it to the Java, and then I go back to my class. So I need to load that dynamic library, system.load library, and native _ C. And then so test2 should work fine, because now this native method accepts a person object and prints its name. So let's run test2, and we get the name. All right, so this is how we access the a field. Now let's obviously this was an object field. Let's try a primitive field. So the int age is 21. So this is a primitive field, and so I don't need to modify anything here. So maybe print name, let's just also print the age. So the header is the same, we are passing the person. So what I'm going to do here, I'm going to, so the J class is still the same, right? It's the same class. So I'm going to create a J field ID, FID2 environment, get field ID, and the person class, the name is age, and the signature is now an integer, I. And again, if you don't know the signature, you go to the Java perspective, to the bytecode view, click on the field, and this tells you the signature I and the name, which is age. All right. So this bytecode view is very useful when we are using JNI, Java Native Interface. So back to C++ perspective. So I get the field ID for the age, which is a primitive. And then when I want to use the field ID to access the value, it doesn't, instead of get object field, I'm going to say environment get double field. So the JVM, the environment pointer here, has all the primitive methods: get double field, get integer field, get float field. So we pass in our instance object, which is person, and the field FID2, and this return obviously a J double. And remember, J double, oh sorry, this should be actually integer. So let's just write it in, get int field, person is the object, FID2, and this return a JInt. And again, JInt directly maps to the C++ primitive types int here, so I don't need to typecast anything. It's just a primitive type, and that's very good because now I can say printf /s. So let's say so age is %d, and I'm going to say name array. So the name and then apostrophe s and then age, and this should be printf. Alright, so let's build this, and the build is done. Let's copy and paste the dynamic library. Okay, and let's go back here and run the method again, and it prints the name and says Bob's age is 21. So we were able to access a object field, a string. The name was an object, a Java object, and also a primitive field. Age was a primitive. Now if I make this private, I don't need to change anything in the C++ code, and this code, this native access should still work, and it does. So, but remember, in the test 1 where we were using the we were using the reflection API, having a private access tells me that you have illegal access exception. So this test access field cannot access a member of class with modifiers private, right? So we still can use this get declared field to get the properties of the field, and this f1 tells me that it's a private. And then once we go to invoke the get method on this field ID, it throws the illegal access exception. And maybe let's also do the same thing for the age. So class get declared field age. All right, and then sysout f2, and then I'm going to say int age is f2 get int, and pass in the person instance. So again, just like the JNI that has get double field, get int field, the reflection API also has get int, get double. It has all the primitive types, and they directly return a primitive. And then sysout name, sysout printf, %s's name, age is %d, and \n. So name and then age. So if I run this, I still get the illegal access exception, and you see that both the name and the age have private access modifiers. And the solution to accessing a private field is to, when we get the field, we say that f1 set accessible to true and f2 set accessible to true. And now we should be able to use the reflection API to access the values of these private fields. So if I run this, it works fine. And let's run both test 1 and test 2. All right, Bob's age is 21, Bob's age is 21. So we are using Java reflection API inside Java to access private fields, and we are using a native field, basically a C++ code, to access the fields of a Java class in Java. And in that case, this is a direct access or unprotected access, so it doesn't care if the field is private or not. We are directly accessing the meta space of the JVM without any checks. But in Java, in reflection API, it has some exceptions, so it checks for the access modifiers, whether or not it's a private or public. But in general, it's possible to access the private fields even using the Java reflection API. You just have to set the accessible to true. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.